Hello, my name is Andrew Argaez. I'm a data scientist, and this is my project Vowel Play. So I have a background in linguistics, and I've done a lot of work in phonetics. So when they told you back in the day A, E, I, O, U were the only vowels, they lied, I'm afraid. There's actually at least 10 cardinal vowels, and these are them in their phonemic alphabet representations. I've worked with a speech processing software called Pratt, and after doing some searching, I found a Parsamouth, a Python library that allows me to use Pratt functionality with Python commands. I recorded 40 people saying 200 monosyllabic words. My total data set is 8,000 audio recordings. I took note of the person's age and gender to later use as features. So on the left, we see Pratt and what it sees with the spectrograms. The red overlays that follow the formants, which I will explain in a second, is the capabilities of Pratt that let me do some pretty cool stuff with speech processing. So formants are different representations of the mouth and the frequencies that are produced from the construction of those areas in the mouth. So F1 or formant 1, right down here, you see that is the representation of the shape of the back of the mouth and the frequency that's produced from that specific part. Now, F2 is a representation of the front part of the mouth and the shaping from there. So we see the words kit and keep, court and cod, and we see keep has a wider spread, kit a little bit closer together, court and cod much closer. And so what my project does is that we look at these formants and the average of these formants, average frequency for these formants. Now, if we look over the graphs on the right, this is what Python sees, or what Parsamouth allows me to do with the audio files. So I can take the audio files and then take an array that I'm graphing here to see what is being said with the frequency. So F1 and F2 also shows up here. And I wrote an algorithm that dissects these smoothed out frequencies, looking at the variance in windows of what I get to decide. I set a parameter that decides how large of a window it slides through these arrays and picks the points that are within a threshold that I also set as a parameter. And it just takes those points and averages them out. So after it does that, it spits them out into my data frame. And so F1 and F2 are obviously going to be very important parts of features for my model. So we can see here on the right, the graph shows that the F1 and F2, just by graphing my recordings by their formant 1 and formant 2 frequencies, it's able to we see some very clear clustering. Now on the left on the chart, these are the average frequency F1 and F2 frequencies for each vowel. A feature that ended up being really important from my project was gender. Women speak in a higher frequency than males, and so knowing my model being able to know what the gender of the speaker actually increased its accuracy by 5%. Another feature that ended up being very important was duration of the vowel. So we know about short and long vowels like E and I, it. In this specific recordings, it is 0.05 seconds shorter, and on average, E was just about the same on average. And so knowing this helped my model's accuracy increase by 3%. Now my baseline was 10%. So what that means is basically that there was 10 vowels, and if my model were to just guess at random, it would have at least a 10% chance for accurately classifying each vowel. I tested over different models and machine learning models, and random forest proved to be the best at 60.3% accuracy. So it was able to classify the vowel 60.3% of the time when looking at the audio file. Now, use cases for this could be used for vocal profiling. And I do a little bit about that with that in my model. The gender, age, And first language and accent could be eventually used when just from a simple sound recording. It also can be used for voice processing or like speech to text. And then further work I would like to do, I would like to link my database to the application I'm about to demo. And then with each time the application would be used, it would add a recording to the database and continue the model's capability. And then adding the capability in my application to be able to evaluate the vowels prediction. You'll see when it makes a prediction, it would be cool if I was able to add the capability of letting it know if it's right or wrong. And then I would also like to improve my algorithm so that it can process multisyllabic words and diphthongs, which are just two vowels back to back. Now I'm going to show you my app that I made, and we'll see it in action. So I hit start listening and engages the microphone on my computer. And then I'm about to say a word, and then it'll classify the vowel in that word. Teen. So here it shows the information that it was able to pull from the recording. The format 1, format 2, the duration, and then the gender. And then it was able to properly guess the vowel. I can do another one. 10. 10. And so here I did it again. And that concludes my presentation. Any questions?